Yes, in this session, we want to continue from what we learned like previous time. That's unit. So, prefixes. Sorry. When we look at prefixes, we learned that they are symbols that are attached to the what unit, right? They are symbols found in the unit, and then they are decimal components that represents um decimal multiples or decimal submultiples. And we look at examples in the previous session. In this session, we are going to use that knowledge to do unit conversion from one unit to another. So basically, when during unit conversion, what is actually happening is that the entire unit is not changing. What is changing is the prefix are changing, meaning the decimal components of the unit are the ones changing. So you can change from kilometer to centimeter. You can change from kilometer to meter. You can change from hectometer to centimeter or millimeter or micrometer. Microjoules to centijoules or all that, right? The same unit, but just that you are changing the prefixes. The prefixes are the symbol data. That's what we mean by unit conversion. So we are going to see how, because these prefixes are decimal component and they carry numbers or they carry powers of 10, they are easy to manipulate when doing unit conversion. So let's see how unit conversion is done. So this is part one, where we will see why it is part one soon. Um, let's look at this. Let's have this as an example. Mm, yeah, grab that. So I have 2 meters. Let's say I have 2 meters, and I have 1.15 Newton, and I have um three whatever what unit joules, 3 joules, right? Now these 2 meters, how would what would that 2 meters be when I want to convert to kilometers? What would this 1.15 Newton be when I want to convert it to millinewton? So yeah, so convert it to millinewton. Or what will this joules be if I want to convert it to microjoules? Or let me use another one, 4 grams. I want you to convert it to mega. So all this gram be in megajoules. So you see megagram. Yeah. You see that the unit conversion, what is basically changing it. So if you look at this first example, these are the units themselves, right? Now there's no prefix attached to them. There's no prefix attached to them. But we are converting from just the mere unit name to a particular one that is having the prefix. And we are maintaining the same value. We are not changing the value. Let's keep that in mind. During unit conversion, we want to maintain the value, the magnitude of the value, right? So we need to make sure we find in a way that the things balances. Okay, so how do we do that, right? Let's convert from mere unit name to another unit that is having to another that is having the prefix attached to it. So yeah, 2 meters to kilometers is a simple what unit conversion. Now let's go to math, right, and look at something. So you know that when you have 1/2, do you agree that this 1/2 is the same as 2/4? I know you also said it is the same as 3/6, right? So how did I do to get a 2/4? It's the same thing if you just simplify it. But then how do I get a 2/4? So 1/2, what I did is I multiply by a factor, that's 2/2. When I do that, the top 2 times 1 become 2, and the bottom 2 times 2 is 4. That's what made me have this. Right? Let's look at the second one. I say I have 1/2 and I multiply by a 3/3 ratio. What do I have? 3 times 1 is 3, and the bottom is 6. That's what I got. So I can do multiple things on this. But then the thing is, you have to make sure that whatever we are using to multiply, right, is like ratio of the same thing, 3/3. So this one is what? 2/2. In mathematics, when you do something like this, you can easily go back to what we are actually increasing, right? So through simplification, we can go back. Through magnification, we can go back. To do the magnification, you need to bring some factor like this to make sure that the actual value, that's 1/2, is still the same value. just as in different form, but they are maintaining the same value. So if you are multiplying, you need to multiply by what? You need to multiply by the same constant, right? The same ratio, 2 over 2, 3 over 2, 3 over 3, and that. So that when you simplify this, or when you cancel this, you still get back your 1 over 2. That's it on that. Now we are going to use that principle, right, to actually do the unit conversion. That's what's basically happening, because in unit conversion, what did we say? What's happening is that we are just changing the prefixes, and prefixes are decimal components, right? So the first example that we wrote first was 2 meter, that we want to convert it to what? Kilometers. Okay, we know kilo is what? From the prefix table is what? 10 to the power 3. Is carrying 10 to the power 3. So we are introducing 10 to the power 3 into this. So to do that, this is what we'll do. So we have to, but then because we want to maintain the value, like that's how we do in math. Kilo is coming, so 10 to the power 3 divided by 10 to the power 3. And meters is here. We haven't done anything to the meters. What we do is that, so right now we haven't changed anything. From here to here, the same. If you cancel this thing back, you will get back your 2, right? Why are we using 2 10 to the power 3? Because what we are bringing is kilo, and kilo is 10 to the power 3. That's why we're using that ratio of 10 to the power 3 over 10 to the power 3. Are we good? So yeah, 2 times 10 to the power 3 over 10 to the power 3. But then, so we are doing conversion. We haven't reached here yet. We have not reached here yet. We haven't reached here yet, right? We haven't changed the kilometer. But then we need to do another process again. Now, the 10 to the power 3 that is in now, we can change it to what? Is the is prefix, right? Is prefix symbol, because we say prefixes are symbols, right? So we are converting to kilometers. So this one, I can represent this top one by K. So if I do that, I have 2 times, so K meters all over 10 to the power 3. Do you agree with that? Yes, because I just changed the top one to 10 to the power 3. So I maintain this guy. These guys, they came together. So yeah, they should maintain. Just that the bottom one did not change to the prefix, but we changed the top one to its prefix form. And the prefix form of 10 to the power 3 is what? K from the prefix table, right? 10 to the power 3, K. So we now have kilometers. Now these are numbers, right? Number cannot associate with the symbol. We have to associate with kilo. So we have the magnitude. So 10 to the power 3, we have what? Kilometers. So it's the same thing here. So basically, what we have is that we have to keep the decimal component up. So it becomes 2 times 10 to the, if you use indices, right? 10 to the power 3 kilometers. At the end of the day, this is what we have for the conversion. So 10 to the power negative 3 is just it was 10 to the power 3. So we change it to the top, like indices, then you have 10 to the power negative 3. So 2 meters is equal to 2 by 10 to the power negative 3 kilometers. You see, at the end of the day, we didn't touch the value. It's the same thing. This is the same as this, but we want to have it in kilometers, right? That's how this unit conversion was done. Let's look at other examples. Let's look at the other examples. Um, yes, let's look at it. I think I need to clean my table. Yeah, so it's cleared. Okay, so now the next example, we use 1.15 Newton, right? And when we want to have it in, what was that? Let's go back there. In millimeter. Hey, millinewton. It should be millinewton, not, yeah. But kilonewton, the name should be the same. So yes, to millinewton. That's what we said. And we know milli is what? 10 to the power negative 3 from the prefix table, right? So watch the previous video to understand what I mean by previous video. So these are the decimal component. They're just symbol representing that. So now what do I do? Now it is not here. Milli is not here. So I need to introduce that. So we need to introduce that by doing what? By making sure we bring this constant ratio. So 10 to the power negative 3. Then we still have our Newton here. We haven't changed anything yet. We're just introducing this to make sure that if you cancel this, you get back this. That's math, how the mathematics work. Okay. So but then we need to change the top one to this prefix symbol, right? The prefix symbol of milli, 10 to the power negative 3 is just millinewton. But we haven't, the bottom one does not change, right? So at the end of the day, we will have 1.15, and then the bottom one we just associate with this guy over 10 to the power negative 3. Then you have millinewton. Now, because of, if you take power negative 3 at the bottom, if you bring it up, we have 10 to the power 3. So positive negative 3 become negative. This is just math, right? 10 to the power millinewton. So this is the answer for this conversion, right? So 1.15 Newton is the same as 1.15 times 10 to the power 3 millinewton. Great. Let's take another example. Yes, let's look at another example. The next one was 3 joules to microjoules. So we have 3 joules, right? We are converting it to microjoules. So we do the same thing again. So 3 joules is 3, right? Micro is what? Macro is 10 to the power negative 6. So 10 to the power negative 6, right? So I'm going to bring in that ratio because we are introducing 10 to the power negative 6. Then we have joules. But then we need to change this stuff to the prefix symbol. So if you do that, so from here we are here, from there we are here, right? It become 3 microjoules over 10 to the power negative 6. So if you do that, we are going to have 3 over 10 to the power minus 6 microjoules. But the decimal component is best to just bring it up. So if it's power negatives at the bottom, we become power 6 at the top. So you see that the value is the same and the magnitude, only the prefix that they have changed. So this decimal component came to cater for that, to make sure that we don't change the actual magnitude of the value. So this is the answer. So conversion from 3 joules to joules, this is the answer. So we'll do the last one, which is 4 gram to megagram. That's mega. So mega is what? So let me keep this one here and quickly do that. Okay, yes. So we have 4 grams to what megagram? We don't know yet. So for the mega, we know mega is what? 10 to the power 6. Yeah, 10 to the power 6. That's mega. So we have 4 times 10 to the power 6 over 10 to the power 6. That's what. So we have grams. Now, if you change the top one to the prefix symbol, we have 4 megagram over 10 to the power 6. So you just 4 over 10 to the power 6 megagram, which is the same as 4 times 10 to the power negative 6 megagram. So this is our final answer for this. So look through this exercise and try a few examples on your own. This is how to do unit conversion, and this is just part one. In the part one, we are making sure that we are changing from a unit that is not having any prefix attached to it to a one that is having a unit, so a prefix. So we have 2 meters, which we converted to kilometers, right? So when you convert it to kilometers, we have, so 2 meters is equal to 2 times 10 to the power negative 3 kilometers. You see that we converted from something that is not having any prefix at all to something that is now having a prefix. That's part one. So in part two, we look at how it also look like. So join us and then stay with us for us to do the second session, the part two of this unit conversion. It's very helpful in engineering and very in physics and entire life, as long as mathematics is concerned and physics is concerned as well, and other subjects. Yes. So you need to understand your unit conversion so that you don't lose marks for that. See you in the next session.